Students, today we are going to see chapter number 5, continuity and differentiability. In that 5.1 exercise, first question we are going to see. Before that, continuous means what? That is, one function is given with what is that, more than one point they asked to check. So one by one we have to check here. Understand? There is no interval, direct point they give. If interval is not given, directly you can check limit point and function value. Function value in the sense directly the value, the 0 we can substitute in the function, which is what we are getting. That is a function value 1 you have to take. Understand? And the limit value in the sense that what is that x value? The x you have to make as a limit. Limit x tends to 0, f of x. Then the f of x you have to write after applying the limit. What you are getting, that is answer number 2. So 1 and 2, if you have a equal, the function is continuous at the respective point. Understand? If it is not, that's it, not continuous, you have to say. This is when interval is not given. Suppose when interval is given, we have to go left hand limit and right hand. So when we have interval, that I will explain. Now at present we will check these things. First of all, let me go at 0. Then at x is equal to 0, what is my answer? Okay, right. So here we have a function f of x is equal to 5x minus 3. So that f of 0, not 3, 0, which is equal to, so that 5 into 0 minus 3, which is equal to 5 into 0, 0 minus 3, which is equal to minus 3. This is called a function value. Now limit value. So limit x tends to 0, f of x, which is equal to limit x tends to 0, f of x, what is that? 5x minus 3. Okay. For this 5x minus 3, we have to apply the limit x tends to 0. Okay. So when you replace x value 0, what I am getting? The same minus 3. Have you noticed it? Function value and limit value equal. When function value, limit value equal, but just a minute, limit x tends to 0, f of x, which is equal to f of 0, means this is function value and this is called a limit value. So both function and limit value equal to minus 3. Then what we can say? Which is continuous at 0. Okay. Then f of x you can write, or function you can write. F of x is equal to 5x minus 3 is continuous. Continuous at x is equal to 0. That you can write. Continuous I wrote CTS. Okay. Right, fine. Like that, same manner, at x is equal to minus 3, we want to check. At x equal to minus 3, what is the result? That we have to check. Okay. And this side, let me go at x is equal to minus 3, what it will be. Okay. So first of all, a function value, f of minus 3, which is equal to function we have. Let me write the function here. What is the function? 5x minus 3. Okay. In the f of x, we have to replace the x value as minus 3. So that 5 into minus 3, which is equal to, this one when you product 5 into minus 3, minus 15. Minus 15 minus 3, which is equal to minus 18. Okay. So function value we got as a minus 18. Then what about limit value? Okay. So limit x tends to minus 3, f of x. The f of x we have to write here. F of x 5x minus 3. Now what it mean actually? It meaning is x approaching minus 3, but we will be replacing instead of x minus 3 only. Understand? So that 5 into minus 3, which is equal to minus 18. This step already we have here. If you simplify, you will be getting minus 18. You'll understand. Okay. So that therefore limit value x tends to minus 3, f of x, and function value f of minus 3, both are equal to minus 18, then f of x is continuous. Okay. Then f of x equal to 5x minus 3 is continuous. Okay. Is a continuous at, what is that? X is equal to minus 3. Understand? So if x is equal to 5, you people try. X is equal to 5, you people try. That you have to do here. At x is equal to 5, you people try. You take as a homework. Understand? In the same manner, how I replaced x value minus 3 in the question. In the first part, x equal to 0, how I replaced. Same manner you want to do at x is equal to 5. Okay? Right. Right, Bhaskar? So continuity differentiability, it belongs to calculus topic. So calculus unit contain almost 5 chapter, Raja. From the 5 chapter, they will be asking 35 mark in the board exam. 35 mark, not a small. Almost it is half of the 50%, 45% of the mark actually. Okay. So kindly give importance to the calculus topic. 5, chapter number 5, 6, 7, 8, 9. These 5 belongs to calculus. Shall we go to next page? Means the next question. Have you done, children? So x is equal to 5 you want to do. Understand? Right. So examine the continuity of the function. So it's like a normal, what we have done the previous, same thing. Just continuity in the sense when accurate value is given, we can go directly function value and limit value. Okay. So f of x is what? That you write f of x, which is equal to 2x square minus 1. So we have to check at x is equal to 3, the function is continuous or not. So directly I'm going to find a function value first. Function value f of 3, 2 into 3 whole square minus 1 means instead of x, I'm replacing 3. That's it. Okay, right. Now when you simplify that, 3 square 9 minus 1, which is equal to 2 nines are 18 minus 1, which is equal to 17. Understand? So this is the function value. 17 I got as a function value, and limit value. Limit x tends to 3, f of x, which is equal to limit x tends to 3. What is the f of x? 2x square minus 1. It means we have to replace the x value as a 3. That's it. The same thing what we have done in the function value. So what it will be? 3 square minus 1. After you simplify this all, we know that it will be 17. Already we have done the same step. We got a 17 here. We knows very well. Okay. So that directly I'm writing as a 17. Now therefore limit value x tends to 3 f of x, which is equal to function value 3, both are equal to 17. If both are function value, limit value, both are equal to a single scalar, what we can say? Then f of x is continuous. Okay, f of x 2x square minus 1 is continuous. Is continuous at x is equal to 3. That's it. So this is the question number 2. Very simple actually. Okay, do it fast. When interval given, there is a, what is that, left hand approach, right hand approach, that we have to go. Other than direct value you can apply. Okay, to check the continuity, direct thing you can check. Function value, limit value alone enough. Don't want to go much thing here. Or else do one thing, I will complete. You people write later. Okay, better. I'll show later. Right. Sorry. I'll go to new page. So examine the what is the following functions for continuity. Continuity they asked to check. Continuity we have to check. Question number 1. F of x is equal to what is that? X minus 5. Have you noticed which is not given here? What is not given here? Yeah, where we have to check not mentioned. See the previous 2 pages. Here at x is equal to what they have mentioned. Here x is equal to 0, x equal to minus 3, x is equal to 5 they have mentioned. So at the point we have checked. Even in the next question also, they asked to check at x is equal to 3. So at where we have to check, they are given na, we can go directly to the function value and limit value I said. But single function is given. It's a single function, but where we have to check which is not given. The continuity where we have to check which is not given. So where you have to check which is not given, what you have to do? Any real number you have to take. What is the real number? Any real number C we will be taking. Okay, right. So that I'm taking a real number. Let C be the any real number. Any real number I'm taking. So I'm taking my own number because the C can be any number, right? It can be 0 or negative or positive or any rational number. That x value can be anything. So that I'm taking a real number. Understand? So at the x, this is actually x value. This is what actually x value. C is what x value. At x is equal to C, we are going to check now. Understand? That's it. Now let me go. Same. This is also now after taking x as a C. This is also now a single value and single function, so that we can go to the function value and directly limit value. Not an issue. So function value first f of c instead of x I'm going to replace c here. So here we have a function. So what you will be doing then? Instead of x, c minus 5. That's it. That is our answer. Nothing. Okay. Now limit value, limit x tends to c. Instead of x value, I am giving x approaching c. C can be anything from the real. F of x, which is equal to limit x tends to c, x minus 5. So instead of x value, we have to replace c, we know. So that c minus 5. C minus 5. Now you can notice function value and limit value both are same. So that what we can say? Yeah, limit f of x, which is equal to f of c, that is equal to c minus 5 is continuous at x is equal to c. It means at any real number we can say, or else instead of saying at x equal to c, you can write in a word at any real number also you can write, not an issue. Understand? Right. Same thing we will be doing for what is that b, subdivision b. But subdivision b, there is a condition. We cannot write c can be any real number. Why? Yes, if you are telling any real number, na 5 also real number. 5 if you are giving, it will become not defined. So that except 5 c can be any real number. That like that you should take. Understand? Right. Same thing only, but x what is that? Not equal to your right. Understand? Okay, you take let x is equal to c be any real number. Be the any real number. Any real number, yes, except what is that? X is equal to 5. Listen carefully. X equal to c be the any real number except x equal to 5. Except 5 you take anything. Why except? This is given by the question. That is what. Okay. Right. Now let me go to normal thing. So what is that? F of c function value. So 1 divided by c minus 5. That's it. Function value is over. And the limit x tends to c f of x, which is equal to limit x tends to c 1 divided by x minus 5. When I apply the c, 1 divided by c minus 5 you will be getting. See, now both are same. So therefore What is that? Limit x tends to c f of x and f of c both are equal to 1 divided by c minus 5. Then then what is that? I'll write. Then f of x is continuous at x is equal to c. Okay, x is equal to c. What is that? Except 5. So f is continuous at c except 5. This is B answer. Can I rub the A1? Is anyone writing A? No, I'm right. C1 f of x which is equal to x square minus 25 divided by x plus 5, and here x not equal to minus 5 is given. Children, listen here. Before entering the function value and limit value, you can simplify the question. After simplifying the question also, you can go. Or else, let me simplify in the answer itself, sir. Now let it be as it is now also, not an issue. You can continue. Understand? Shall we simplify in the question itself or else in the answer? In the question itself, that is better. Question itself, if you simplify, this is look like a x square minus 25. We can write 5 square divided by x plus 5. Algebraical simplification you can do, not an issue. Yeah, so that x plus 5, x minus 5 we can write divided by x plus 5. So this x plus 5 cancelled. Finally, I am getting x minus 5 is my f of x. Okay, so what formula I used here? I used a square minus b square is equal to a plus b into a minus b. That's it. We understand? So this is the formula which we are used here. We understand, children? So f of x is equal to what we have now? A simple function x minus 5. Now for the x minus 5 you can do. So what we have done for x minus 5, what actually, this is a question, have you noticed? Yes, then the same answer can you take? But that after simplifying it became nothing, the x not equal minus 5. Okay, after simplify it became nothing. So it's like a a1. Understand, Raja? It's like a1. So directly if you are simplifying after applying c instead of x, c you can simplify for function value and limit value, not an issue. Both are okay, same answer only you will be getting. So you write the a answer for c1. Hereafter the same function value f of, I mean what you have tried here. Let c be the any real number. C be the what? Any real number. Okay, c be the any real number here. X is equal to c. What actually? X is equal to c. Be the any real number. Okay, and f of c is equal to c minus 5. Limit value na x tends to c f of x. Limit x tends to c f of x what? X minus 5 c minus 5 you will be getting. Both are same answer na. Then f of x is continuous. Continuous at x is equal to c. That's it. After simplifying also you can do the Raja, or directly with the given question also we can do, not an issue. Okay. D question, this is different. Just listen, I will do. Okay, pa. Have you done everything? A D question little big actually. They ask in 2 mark. D question little important. Okay. For D only you give a important. Even a C also, but D is little important. They will ask 2 mark. Suppose if you have a luck na, they will ask even in 3 mark. Based on that, it will be. Shall we go next ma? Have you done everything? Shall we go next pa? So f of x is equal to modulus of, what is the D1? F of x is equal to modulus of x minus 5. Modulus of x minus 5. Okay. So this is I have taken there. F of x is equal to modulus of x minus 5. For this we have to check the continuity. But generally modulus function, listen children, in 11th standard we have studied this. Generally modulus of x na, wait, here I'll write. So modulus x in the sense, what it mean will be doing plus x minus x. Am I right? So plus x na x value. What is inside the modulus? That it will be greater than or equal 0. What is inside the modulus? That will be less than 0. When plus minus we have in the modulus, we will be writing the interval like that. Okay. But here inside the modulus, not like x, this is x minus 5. So this question also will be changing into what? What is that? Plus x minus 5 and minus x minus 5. When it will be inside the modulus, what we have? X minus 5 greater than or equal 0 and x minus 5 less than 0. This is the step you should learn here. When modulus is there, there is a work. Okay, be careful. Now it became what? This one became what actually? That you see. Now x equal to what? X became here. Minus 5 when it's in opposite, x greater than or equal to 5. And here down, x minus 5 when it's in opposite, less than 5. Then there is a interval. Have you noticed it? The first step, plus 5 na, 5 and above. X value is what? 5 and above means close interval 5 to infinity. This one meaning, am I right? X value is what? 5 and above. You can take anything. Okay. And like that, this one is what? 5 and below. So that minus infinity to plus 5. So that the interval is going till plus infinity and minus infinity from, what is that? 5. So 5 approaching from left hand side, 5 is approaching from right hand side. At the 5 also it is happening. So totally 3 case it will be divided. How many cases? 3 case. Understand? Right. But in question here also, at what? It's not mentioned. Means at what place? Actually approaching from left hand side. But what limit? X0 or what? Nothing is mentioned. I'm right. Okay. But at x equal to 5 we can use a 5. But other than that, nothing. So that you have to go with C only. For left case and right case you have to go with C. Understand? And middle case at x equal to 5 na, there the meaning is what? At x equal to 5 you can check function value, limit value directly. Understand? Now let's go to the answer. So I'm going to divide into 3 cases. This is okay, 3 cases. What is that? Case number 1. Case first, let me write. Let C be the any real number. I told you C means x value. Okay, C means x value. That is x is equal to C is the mean. Case number 1, what na? X greater than or equal to 5. X greater than or equal to 5 means what? X greater than or equal to 5 na? That is C greater than or equal to 5 is the meaning. Okay, the x only I wrote as a C. Okay, C greater than or equal to 5 we have to check. So greater than or equal to 5, listen, when C greater than or equal to 5, how many functions we have? Can you tell me? When C or x greater than or equal to 5, how many function we have? Only one function we have when x greater than or equal to 5. Am I right? Am I right? Only that function we have to use. What function that is? f of x is equal to x minus 5 alone you have to use. So we have one function and one x value. Now what you will be doing? Directly function value and limit value will be using. Am I right? So here also I'm going to use directly function value. What is that? At c we are checking. C don't take 5 because 5 and above this is meaning. So c only we have to substitute. Okay, just c which is equal to, so c minus 5. When you check what I'm getting, c minus 5 in the, instead of x, if I'm replacing c now, you will be getting c minus 5. Like that, limit. So limit x tends to c f of x, which is equal to limit x tends to c function what ma, x minus 5. X minus 5, instead of x, if you replace c minus 5. Now both are same. So therefore limit value f of x and f of c both are is equal to c minus 5. Then f of x is continuous. At what actually, c greater than or equal to 5 na, it is in the positive direction, which is continuous, or 5 and above, which is a continuous. You can write, or directly you can mention that at c greater than or equal to 5, which is a continuous. Case number 1. Case number 2. Okay, this is since case ma. This is like a rough work. Case number 2. Case number 2, what we have? X less than 5, which means c less than 5. C less than 5 na, how many function we have? Very good. Only one function, that is the function. Here also you can replace that. Take the negative multiple inside ma. This minus you multiple inside. So what I'm getting? Yeah, plus 5 minus x. So that I multiplied the negative inside. Now it became question is different. Okay. Now that I will be using here. So that what is my function? F of x is equal to 5 minus x. So this is I'm using. After I multiply the negative inside, it became like that. Okay. Now directly function value f of c, which is equal to what I'm getting, 5 minus c. That's it. And limit value x tends to c f of x, which is equal to what is that? Limit x tends to c f of x what? 5 minus x. So 5 minus c. Answer number 1. So therefore limit x tends to c f of x, which is equal to f of c, that is equal to 5 minus c. Then f of x is continuous at x, not x, c less than 5. Okay, right. Now case number 3. Case number 3, what na? At x is equal to 5. What my dear? X equal to 5 na? C equal to 5 is the meaning. But when we have a c equal to 5, there is a 2 case. Listen carefully. At c equal to 5 na, you should be very careful. So minus infinity to plus infinity, there is a 5. At x is equal to 5 na, there is a left hand side approach and right hand side approach. Have you noticed it? So here only we have to do left hand limit and right hand limit. So left hand limit means very simple pa. Left hand limit, LHL means left hand limit, which is equal to limit x tends to 5. I'm not using here c. Have you noticed? Because we have here x value equal to, if it is given, we have to use that value directly. Okay, this is like first 2 question. Here x equal to 0 na, 0 we used. X equal to 3 means 3 we used. Same manner, here we have x equal to 5 means x equal to 5 I will be using directly. Understand? Right. So that, sorry, left hand limit. Left hand limit now you have to put negative, because from the negative side it is approaching. I'm right. Don't think, listen, don't think minus 5. This is not a minus 5. The minus, why we are mentioning in the 5 power na, from the negative direction which is approaching the function. That is the meaning. Okay. Right. And f of x. So that you have to check from the negative side. If you approach what function, it means 5 and below. Listen carefully, this is very important, everybody listen. Children, limit extends to 5 to the left hand side approach. Left hand side means 5 and below is the meaning. 5 and below means 5 and below. Now what is the meaning? 5 and below means what is the meaning? What is the meaning? 5 minus x is the meaning. So that the function is what? 5 minus x you have to use. Very careful. Have you understand? So that what you will be getting here, instead of x, what we have to substitute now? That is what? Not minus 5. Okay, the minus only for checking the direction, left hand side or right hand side. Okay, right means plus, left means negative. Now just 5 we have to give. So 5 minus 5, what you will be getting? 0. What I'm getting here? 0. So 0 is my answer. Like that, right hand limit or HL, right hand limit, which is equal to limit x tends to 5 plus f of x. Plus in the sense what it means? 5 and above. 5 and above. Okay, as per the question, 5 and above. So that limit x tends to 5 plus 5 and above means where we have 5 and above. X minus 5. What is that? X minus 5. So that x value 5 plus, it means just 5. Okay, just 5 we have to give. 5 minus 5, which is also equal to 0. Not yet over. We have to check left hand limit, right hand limit and function value. Okay, function value means what? F of 5. Directly f of 5. So where you will be substituting function value? Where the 5 equal to x, there only we have to substitute. Okay, so here the 5 not equal to x. In first case there is a equal and greater. So that equal place, what is that? X minus 5. That you have to take. Okay, that you have to take. So that what I am getting? 5 minus 5. Listen carefully. Okay, listen carefully. What is that? X minus 5 at x is equal to 5. X is equal to 5 na? X minus 5 function only I should use. Very careful here. So that 5 minus 5 is 0. So finally what you have to say? Therefore left hand limit, right hand limit and function value f of 5, everything equal to 0, then which is continuous at case number 3. So that listen carefully, case number 1 continuous, case number 2 continuous, even case number 3 continuous na. Therefore which is continuous for all real number we have to mention. Okay, so that then f of x is continuous at x equal to 5 you have to write. X equal to 5. So finally you have to write one word I said na. What you will be writing that? So hence f of x is continuous for all real number. For all real numbers. That you have to write final word. Okay, hence f of x is continuous for all a real number you have to write. Okay children, we'll end this session. We'll continue in the next video. Thank you children. Take care. Bye.